Question 6 on the practice exam is a single exponential smoothing problem, and we're given some information here in a table, and it tells us use alpha of 0.25 to calculate your forecast for time periods 1 through 4. Okay, and we'll use 200 as our starting point. Okay, so alpha equals 0.25. That is our weight, and so that is, if you look at this formula here, our actual value, this portion, the actual number that we say sold, if this is a sales forecast, is given a 25% weight. So we're saying we will give our current value that we've sold 25% of the weight, and our forecast 75%, right, with the 1 minus alpha, based on what we think our forecast will be. Okay, so if we're going to fill in the table, we've got this 25% alpha, and we've got 200 as the initial forecast. Okay, so there we say 200. There, we're just given that. You have to start with some arbitrary value that you select. And so what we'll do then, we'll calculate this equation right here, and that would be then 0.25 times 200, our y value, 200, plus 1 minus 0.25 times our initial forecast, which is 200. Okay, and you probably see where this is going. We're taking 25% of 200, right, which would be what, 50? And we're taking 75%, or 1 minus 0.25 is going to be 0.75. We're taking 75% of 200, which will be 150, equals 200. Okay, well that's pretty easy, right? So our first one is going to be the same, and that would be the case always, right? And that this is just going to carry across. And then what you want to do then is you move then this number down here. So then you have 200, you carry that down. Okay, and then we'll do this same exercise here. We'll now say with 0.25 times, now our y value is 400. 400 plus 1 minus 0.25 times the value we just brought down, which is 200. Okay, and so then this would be 25% of 400 would be 100, plus 75% of 200 would be 150, and then this is going to become 250. Okay, so then our forecast for period 2 is 250. We bring that down here, so then this becomes 250. Okay, so we've got the actual of 240, and then our forecast of 250, and we would perform this same thing again. We'd take 25% of 240 and 75% of 250. We add those together, and then we would get 247.5. Okay, bring that down here. So we have 247.5. Then calculate again, 310, 25% of that, and 75% of 247.5, and then our result here in this last one is 263.125. So that's how you calculate that forecast. And again, what this does is you decide with the alpha that you give how much weight you're giving to current sales versus what your forecast is, and take it accordingly, and calculate that, and then you can test it against that. And so this is good if you're trying to smooth out an uneven forecast. If you're in the initial stages of demand, you maybe don't want to take, for whatever reason, you had some unusually big sale or unusually small or bad quarter, for example, you would then adjust your alpha accordingly and decide how much of the actual value you want to take and how much your future prospects will play into your forecast. And so one of the advantages, well, two of the advantages of this over linear regression gives the same weight to all values in the forecast, right, from start to finish. So if you have a pretty stable process or sales, if you're doing sales, that's probably a good way to go. If you're in a startup, however, where sales might be kind of lumpy, jumping all over the place, and you want to give more weight to recent data, the single exponential forecasting method might be preferable. All right, and so we answered part A here by filling out the table. Part B says if you were to change your forecast right here so that alpha is 0.1, it would result in more or less smoothing. So you could calculate all of these out and do this table again, or you can just kind of think about it and say, well, if I'm giving alpha is 0.1, the smaller the alpha, the more smoothing there will be in your forecast. If you give more weight, on the other hand, if your alpha were high, if it were 90%, right? If you flip those, you're giving more weight to the actual sales, and then it's going to be less smooth. It's going to jump around more because of the weight that you put on it. But in this case, because we've got a smaller alpha, we would get more smoothing rather than less.